Chemistry 20. How's it going, everybody? Today, we're going to do a lesson on chemical indicators. Now, chemical indicators are not overly challenging to understand and how they work. And how they work is by measuring the pH, the hydronium ion concentration found within a solution. Now, they can be used if we don't have pH meters, and we can use them to help us calculate a concentration of hydronium ion, like I said. Now, indicators are substances whose color changes with a varying degree of pH. Now, let's look at some examples. All of these are found in your data book. The indicator, the pH range to which they will change color, and the color changes that will take place. So the first one is, let's look at methyl red. Now, methyl red, oh, by the way, all indicators are all just weak acids, and they change color at different pH points. Okay, so they're not all the same. They can be used for varying degrees of hydronium ion concentrations. Now, let's look at methyl red. Okay, now methyl red will change color between 4.8 and 6. Now, if I take methyl red and I put it in a solution of hydrochloric acid, which we know has a really low pH, methyl red will be red, because I know that a hydrochloric acid has a pH of about 1.5 or so. Okay, 1.5 is less than 4.8, therefore methyl red will be red. All right. Now, if I put methyl red in a solution of NaOH, which has a pH of about 13 or so, I know that methyl red is going to be yellow, because methyl red will change color to yellow anything greater than 6. Now, bromothymol blue will change from yellow to blue in a pH range between 6 and 7.6. So if I use the same examples of hydrochloric acid, if I put bromothymol blue in hydrochloric acid, it's going to be yellow. If I put bromothymol blue in NaOH, it's going to be blue. But if I put bromothymol blue in something neutral like water, I would expect it to be green, because it's intermediate between yellow and blue. H2O has a pH of about 7, as we know, and 7 is between 6 and 7.6. So we would expect it to be somewhere in that green category, somewhere intermediate between yellow and blue. Now, indigo carmine, one of my favorite indicators, has a pH range of 11.4 to 13. So that's where it will change color. So if we take hydrochloric acid and put indigo carmine in it, we would expect indigo carmine to be blue. However, if we take indigo carmine and put it in a solution of NaOH, we would expect it to be somewhat yellowish, because NaOH falls on that upper end of indigo carmine. Another indicator that we can use is just your universal indicator, and you probably created something like this when you were in grade 9 or 10, where you use cabbage as a universal indicator that will change color at different pHs. So that's another kind of indicator we can use. A universal indicator will change color at basically every pH point. So here's an example of some of the different indicators that you have in your data book. So methyl violet, for instance, will change color only between 0 and 1.6. So for instance, if we were to use water, which we know has a pH of about 7, if we were to put methyl violet in water, we would expect it to be blue, because it will change blue anything greater than 1.6. If we skip down, we won't go through every single one of these. Bromocresol green will change yellow to blue between 3.8 and 5.4. So hydrochloric acid, HCl, if we were to put bromocresol green in it, hydrochloric acid has a pH of about 1, which is less than 3.8. We would expect it to be yellow. If we were to use NaOH instead, NaOH would be obviously about 13. 13 is greater than 5.4. we would expect it to be blue in NaOH. All right, so let's look at some examples as to how we can use indicators to figure out the pH of a solution. Now we need to use more than one indicator to determine or to estimate the pH of an unknown solution. So we have an unknown solution. We don't know what it is. We don't know if it's an acid or a base. So what we're going to do is we're going to start up by putting methyl violet in it. And what we notice is that when we put methyl violet in it, the color turns blue. So if you look up methyl violet in your data book, you see that methyl violet will turn blue as long as the pH range is greater than 1.6. So let me just change my pen here. So methyl violet will change pH to blue, or will change blue in a pH of greater than 1.6. Now, we put a second indicator in a second sample of this solution. The second indicator we're going to use is going to be methyl orange. We see that methyl orange is yellow. That means that the pH of the solution has to be greater than 4.4. Now, if we use methyl red, now we're going to use methyl red. We see that methyl red is red when we put it in this solution. So therefore, we know that the pH has to be less than 4.8. And the last indicator we've decided to use is one that will change color in a higher pH, which is going to be phenolphthalein. Now, little clue as to what might be under this box. If we know that methyl orange was yellow, and it will only change color greater than 4.4, and methyl red is going to be red, and it will, so therefore it has to be less than 4.8. Phenolphthalein, we know that the pH has to be between 4.4 and 4.8. So we would expect phenolphthalein to be colorless. So therefore we know that the pH has to be less than 8.2. So what are some patterns that we can identify from here? Well, we know that the pH of our unknown solution has to be greater than 1.6, greater than 4.4, but less than 4.8, and less than 8.2. So that we can make an assumption or conclusion that our solution is between 4.4 and 4.8. Let's do another example. Let's try another one. We have an unknown solution, and we take our indicator and we put it in. And what we see when we take indigo carmine and put it in, the solution is blue. So we know that the pH has to be less than 11.4. I take a second indicator, phenol red, and I put it in, and I see that it's yellow. So therefore, I know that the pH has to be less than 6.6. So now indigo carmine is pretty much useless to us because we just keep decreasing our pH. I take Brahma Crescel green, and I put that in my unknown solution, and I see that it's yellow. So therefore, I know that the pH has to be less than 3.8. So now our first two that we've used are useless to us. Lastly, I take methyl orange, and I put it in my unknown solution, and I see that it is orange. Now, methyl orange will change color from red to yellow between 3.2 and 4.4. So I know that the pH of this solution has to be between 3.2 and 4.4 because orange is an intermediate color between red and yellow. So the conclusion that I can make, knowing full well now that these two are of really no help to me, I know that my solution has to be less than 3.8, but between 3.2 and 4.4. So I know that it has to be between 3.2 and 3.8 is the conclusion that I can make here. 3.2 to 3.8. All right, so there's a little quick lesson for you on indicators. Have a great day, everybody. And the next lesson will be your last one in this unit on titrations and how we use indicators in titrations. Have a wonderful day. We will talk to you super duper soon.